Hi everyone, I'm making this supplementary video just to go over some topics that originally I didn't think I needed to go over, but I decided that I was going to go over them just to better prepare you for the rest of the course. So I listed the sections that these come from and then the topics that I'll be going over, so hopefully this is helpful. It's basically covering some material from section 1.3, 1.4, 1.5. So make sure to go ahead and watch the video. So from 1.3, I'm really going to be going over the difference of squares, so factoring and the perfect square trinomial, and then factoring with fractional exponents. And this will also help you complete some of the homework problems that I assigned. And section 1.4, division of rational exponents, or expressions, And then section 1.5 is fourth degree equations using U sub and like a fractional powers equation and finding real solutions for the quadratic equation. So from section 1.3, the difference of squares is probably the biggest one that comes up occasionally. That's like a special factoring. And then we have our perfect square trinomials, which are these two, and then occasionally difference of cubes and sums of cubes. So I'm going to go over examples of each of those. So these first two examples are for difference of squares. So we have 4x squared minus 25. So we can see that it follows our form because 4x squared is really 2x squared because 2 squared is 4. So we could pull that squared out. And then 25 is really 5 squared. So we see we have the form. We have a squared minus b squared. So we have 2x squared minus 5 squared. So we're going to use our equation to rewrite that, or our formula. So I'm going to rewrite this as 2x minus 5 and 2x plus 5. So really it's taking what we're squaring as our terms, and then you just put a minus and a plus in each. Okay, so for our next example, we have x plus y squared minus z squared. So what are we squaring in each? So on our first term, we're squaring x plus y. So that's our whole a term. And then z is our b term. So I have x plus y, this is our a, and then x plus y, and then z is our b, and then we just put minus and plus in both. Alright, now our next examples are going to be perfect square trinomials. So as we can see, the equations for those are these. So I have a squared, it could be plus or minus, but it's 2ab plus b squared. And then the plus or minus in the middle makes a difference on what equation you use. So I have, for our example, x squared plus 6x plus 9. So my a is x, because a squared is x squared. And then my b, that's going to be 3, because 3 squared is 9. And then 2ab is, I'm taking my a, which is x, and then my b, which is 3, so 3x times 2 is 6x. So that's the middle term, what I highlighted in pink. So that's 2ab. So we have the form. So we could go ahead and use our formula. So I do a plus b squared because we have a plus sign in the middle here. So I'm going to go ahead and do x plus 3 squared. Alright, so for part b, I have 4x squared minus 4xy plus y squared. So I'm going to go ahead and write my a, my b, and my 2ab to check if it's the right form. So my a is 2x because 2x squared is 4x squared. My b is y. And then I'm going to do 2x times y, which is 2xy, times 2, which is 4xy. So my middle term is 4xy, so it does follow the form. And so I could use my perfect square formula, and we have a minus sign here. So I'm going to go ahead and use number 3 of the formulas. So I have 2x minus y squared. Alright, now this example is a sum of cubes. So I'm going to go ahead and look. So sum of cubes is a cubed plus b cubed. So x squared is actually, you can rewrite that as x squared to the third, because we multiply these exponents, and then it's x6 to the sixth. So I have x squared to the third plus, and then 8 is 2 cubed. So I have a sum of cubes form here. So my a is x squared and my b is 2. So if I follow the formula, I'm going to write a plus b. So I do x squared plus 2. And then a squared. So I go ahead and do x squared squared, which is x fourth, minus ab. So I do minus 2x squared plus b squared. So plus 4. And that's my final answer. Okay. So now this example, we're going to just practice factoring completely. So we're going to factor out, in this example, our x and y with the smallest exponent, because we want to make sure when we factor, we're not overdoing it. So we have to factor out the smallest that's in common to both. So our x terms, that just x by itself is the smallest, so we factor that out. And then y squared and y to the sixth, the y squared is the smallest, so we go ahead and factor x y squared. I'm left with x4 to the fourth minus y to the fourth. And then this equals this form. And then we take a look at it and think, okay, can we factor any more? And so as we can see, we have a difference of two squares. So our a is x squared and our b is y squared. So we go ahead and do x y squared, and then I do x squared plus y squared, and then x squared minus y squared. And as we can see here, we have another difference of squares. So be careful for our difference of squares. Like for this first one, we have a plus sign in the middle, so it's not a difference of squares, it has to be a minus. But this one is our difference of squares. So I do x squared plus y squared, x plus y, and then x minus y is our difference of squares, because our a is x and then our b is y. Okay, so this is our fully factored form. We can't factor x squared plus y squared anymore, so we just leave it. Okay, and then this next example is factoring with fractional exponents. So again, we want to factor out the things that are in common, but with the smallest exponent. So I want to factor out the 2 plus x with the smallest exponent. So minus 2/3 is smaller than 1/3 because it's negative. So that's the smaller one. So I factor it out. And so I factor 2 plus x minus 2/3 from the first term. And I'm just left with x. And then the second term, I'm going to go ahead and subtract the exponents to factor it out. So I'm going to go ahead and do 1/3 minus negative 2/3. So that becomes 1/3 plus 2/3, which is just 3/3, which is 1. So I'm just left with 1. So I have 2 plus x, negative 2/3, x plus 2 plus x, because this is 3/3, which is 1. And then I could go ahead and do some arithmetic here in the brackets. So I could do 2 plus x, negative 2/3, times 2 plus 2x. And then I could factor out a 2 that's in common here. So I'm just left with 2 times 2 plus x minus 2/3 times 1 plus x. Okay, so moving on to section 1.4, which was dividing. Rational expressions I find is sometimes really tricky for students, so I'm just going to go over an example here. So here I have this rational expression divided by this rational expression. So I'm just going to go ahead and factor everything and then do the division at the end. So really this is like the form, this form. And you can, what I did is I factored it and wrote it like top on bottom like this, and then I canceled stuff. But you could totally, from this step, since it's division, you can flip the second and multiply. So if you want, you could change it to multiplication, do this, and then factor and then cancel, but I just did that at the end. Okay, so my first step is I factored. So I went ahead and factored, let me do this a different color. I factored the blue part first. So I'll go ahead and do that. So I had 2x squared minus x minus 15. I factored that first. So I do 2 times negative 15 on top, so it's negative 30. And then the middle term is negative 1. So I did negative 30 on top, negative 1. So I thought, what times what is negative 30, but when you add them, you get negative 1. So 6 times 5 is 30. And then I want to choose where to put the minus sign in order to get a negative 1. So I did negative 6 plus 5 is negative 1, and then also negative 6 times 5 is negative 30. So be careful when you're rewriting it. It's not just x minus 6, x plus 5. You have to do it 2x squared minus 6x plus 5x minus 15. And then you put these terms depending on these values, because we're going to want to factor. So you have to match like the common terms. So I did 2x squared minus 6x because I didn't want to put 5x there because 2 and 5 don't have anything I could factor out. So I go ahead and factor out a 2x, and then I'm left with x minus 3. And then 5, I factor out a 5 here. I did 5 times x minus 3. These should be the same. So I do 2x plus 5 here, and then x minus 3. Because I'm factoring out the x minus 3 essentially. So that's my top, this one. Now I'm going to do the bottom of the top. So that's just x squared minus 2x minus 3. I take my minus 3 and my minus 2. And negative 3 times 1 is negative 3, and negative 3 plus 1 is negative 2. So I have x minus 3 and x plus 1. So that's my top term. Now I'm going to do the bottom red term. So I have 2x squared plus 3x minus 5. It's the same thing. You do our x factoring. So I have negative 10 and 3. 5 times negative 2 is negative 10, and 5 minus 2 is 3. So I have 2x squared, and then I put the minus 2x with that one, and then the 5x minus 5. So then I got 2x plus 5 times x minus 1. The bottom is a difference of 2 squares for my 1 minus x squared. So I have 1 minus x times 1 plus x. And then I just put everything together. So I had 2x plus 5, x minus 3, over x minus 3 over times x plus 1. So here I'm able to cancel my x minus 3 and my x minus 3 because they're on top of each other. And then the bottom I have 2x plus 5 times x minus 1. And then I rewrote the difference of 2 squares. I just, I factored out a negative 1 just to get it to be in the form x minus 1 for this one. So I factored out so when I factor out a minus 1, I'm left with minus 1 plus x because I wanted it to be in that form. So I could cancel the top and the bottom, these x minus 1 terms. So then what I'm left with is 2x plus 5 over x plus 1 over 2x plus 5 over negative x plus 1. So this is where I do the division now, this big division bar, which you could have did at the beginning, but I just chose to do it at the end. So I have 2x plus 5 over x plus 1 divided by negative 2x plus 5 over x plus 1. So multiply and flip the second. So I'm able to cancel the 2x plus 5s and the x plus 1s, and I'm left with a negative 1. So usually everything doesn't usually cancel out, and we're left with a rational expression still, but in this case it did. So we're left with a negative 1. Okay, section 1.5. This was doing practicing doing u substitution for if we don't have an exact x squared power and we're wanting to solve it. So when we have something that's like a factor of 2, so basically any even number, we're able to use our u substitution doing x squared. But you could use u substitution for anything else really, as long as we specify what our u is. So for this example, I have x to the 4th minus 8x squared plus 8 equals 0. So I'm going to rewrite my x to the 4th. So I go ahead and rewrite that as x squared squared, which is kind of like when we did our difference of 2 squared when I'm rewriting things. So that's the same as x to the 4th because 2 times 2 is 4. So here I'm going to go ahead and let my u be x squared, because if I go ahead and do that, then it's going to be the same. Now we have like a quadratic form. So I have u squared minus 8u because my u is x squared plus 8 equals 0. So I do that to achieve that quadratic form, basically. And so whatever's inside here, that's going to be my u. So now I could go ahead and do the quadratic equation for this one because x factoring doesn't work. So I have u equals negative times negative 8 plus or minus negative 8 squared minus 4 times 8 over 2. And then I have 8 because it turns positive here, plus or minus square root of 64 minus 32 over 2. So that becomes 8 plus or minus square root 32 over 2. And then in the radical, that becomes 16 times 2 because I want to simplify the radical. Since the square root of 32 doesn't have a root, I'm going to break it up into factors to see if there is one. So I have 8 plus or minus square root. 16 times 2 is 32. And I know 16 is a perfect square. So I do square root 16 times 2 over 2. So I have 8 plus or minus, and then square root 16 times square root 2. That's how it breaks up. So square root 16 is 4. So I have 8 plus or minus 4 square root 2 over 2. And this example kind of does two things that I wanted to show. In the beginning, when I said the different things, and I had like quadratic equation, find all the solutions, people usually have trouble from this step because they want to just cancel the 8 and the 2 and leave it as 4 plus or minus. Usually people do this, which is wrong. We do not want this. So what you're supposed to do is essentially factor out in the top the common factor. So here we can see that 8 and 4 have a common factor of 4. So I go ahead and factor the 4 out. So I'm left with 4 times 2 plus or minus, because 4 times 2 is 8. 2 plus or minus square root 2 over 2. And now I could cancel. So I could cancel the 4 and the 2. And I'm left with the 2 still on the top. So I have 2 times 2 plus or minus square root 2. And then I could multiply the 2 back in. So I'm left with 4 plus or minus 2 times square root 2. So this is what our u is equal to. But then remember, we said our u was equal to x squared. So don't forget to plug the x squared back in, and then we'll solve for x. So x squared equals 4 plus or minus 2 root 2. So I take the square root of both sides, and then x equals plus or minus square root 4 plus or minus 2 square root 2. So that's all right. Now we're going to do u substitution with some fractional powers. So I have x to the 1/3 plus x to the 1/6 minus 2 equals 0. So in this case, I'm going to try to figure out how to get it into a quadratic form. So I'm going to go ahead and let u equal x to the 1/6 because my x to the 1/3, it can be expressed as x to the 1/6 squared. So that's because 2 times 1/6 equals 2/6 equals 1/3. So I'm going to go ahead and let u be whatever's inside here. So I have x to the 1/6. So I have u squared plus u minus 2 equals 0. I go ahead and just do my x factoring. So I have -2 and 1. So my factors are 2 and -1. So I have u plus 2 and u minus 1 equals 0. So I split those up using my zero product property. And I could go ahead and plug in my x back in, but I'm just going to go ahead and get the u by itself and then plug x back in. So I get u equals -2 and u equals 1. So now I'm going to go ahead and plug it back in. So I have x to the 1/6 equals -2 and x to the 1/6 equals 1. So I take each side to the 6th power to cancel out the 1/6. And then I get x equals 64 and x equals 1. And I'm going to go ahead and check my answer because originally this equation looks like this. And sometimes with radicals, our answers get a little weird. So I'm just going to check my answer. So I find out x equals 1 checks out, but my answer for x equals 64 does not. Because 64 to the 1/3 plus 64 to the 1/6 minus 2 equals 4 plus 2 minus 2, which equals 4, but that does not equal 0. So my x equals 64 answer doesn't work, but my x equals 1 answer works. Okay, so that's it for this video. Just wanted to go over some things that originally I didn't think I needed to go over, but then I thought it'd be best if I did. So I hope you guys find that helpful and you're able to practice these skills in the homework. So thanks and see you later.